everyone, good morning, afternoon, or evening from wherever you are. Welcome to the live stream for the what's new in version 5.1 in the JavaScript Maps SDK. So this is our product team. We're very excited to show all the amazing new features for you. Please post in the chat where you're joining us from, and we will get started. We have a really jam-packed agenda, so let's get right into there. So I am Yixuan Emily Hope. I'm product manager for web development development technologies, focusing on the SDK and also our open source technologies. I'm based in New Jersey. And then Anne.
Yeah, hi everyone. My name is Anne Fitz. I'm a product engineer on the JavaScript SDK, focused on our map components and also some of the visualization and symbology. I'm based in New York. Pass it over to Androl.
Thanks, Anne. Hi, my name is Androl Batsuk, and I'm a product engineer on ArcGIS Maps SDK for JavaScript team. And I focus on a lot of different features like layers, raster and vector tile layers, and also work on a lot of different parts of the map view component. And I'm here today to talk about few enhancements I was part of at 5.1. To you, Jose.
Thanks, Andrew. I'm Jose Bañuelos, product engineer, also for the Maps SDK team. I work primarily on the sketching, so drawing, and also the editing workflows. I'm excited to share the workflows we're releasing. Now passing it to you, Katia.
Hi, I'm Katrina Hobbs. I'm a product engineer on the 3D side of the JS SDK team. And I'm calling in from the Zurich office where we have the Web 3D team, where I mainly work on developing 3D rendering and navigation capabilities. Passing this to you, Russell.
Thank you. I'm Russ Roberts. I work on a lot of the data visualization side of things between new symbols, smart mapping styles, also just visualizing new fonts and labeling enhancements. And I'm located in the remote office in New Hampshire. Tossing it back to you, Emily.
Great, welcome everyone. And I see we have friends joining everywhere around the world, from Ohio, Switzerland, Brazil, and San Diego. Now we're going to get started. So first we'll have Anne sharing the visualization updates.
Yes, let me go ahead and share my screen. All right, so I'm going to talk about a few exciting enhancements to some visualization and rendering capabilities in the API at 5.2. The first that I want to talk about is scale-based rendering. So right now I'm showing a screenshot of Pro. You may be familiar with this experience in Pro, where for a unique value renderer or a class-based renderer, you can define scale-based symbology. So you can set a certain scale for one symbology and then add another symbol and set another scale. And as you zoom in and out of the map, when that scale changes, it'll flip to the other symbol that you've defined. So we now support this in the JavaScript SDK. I'll show an example in the map viewer. Here we have the same map that was authored in Pro, looking at recreation spaces in the New York area. And as I zoom in on the map, you'll notice that the symbology changes to show the polygon feature with a simple fill or with a fill symbol. And as I zoom out, we'll switch to displaying the polygon centroid so that the map, so you can see all the areas once the polygons are no longer visible. So this is supported in the API. You can see it here in the map viewer, and we'll add an authoring experience in map viewer for you to add this to your symbols and your renderers in the upcoming releases. How this is supported in the API is with this new property called alternate symbols on a unique value renderer or a class breaks renderer. And this allows you to define a sim symbol with a min and max scale. This will be like the default symbol that's used by the renderer. And then you can define an array of alternate symbols. So these will, when rendering the data, it'll first look at the min and max scale of the default symbol, and then it'll go through any of the alternate symbols defined, find the matching scale, and then pick that to display as the render or as the symbol in the map. So that's the new scale-based rendering. Another exciting enhancement that is kind of coming from Pro to the web is the symbol layer drawing. And so this previously was not supported. And so when you would load a map with a lot of cased line symbols, kind of like this, where we're looking at transportation routes in the Houston area, you see a lot of like overlapping symbols here where, you know, the case line ends, the next feature begins, and you get like a weird kind of cap at the end of the line. The symbol layer drawing allows you to define how the different symbol layers inside of that sim symbol are drawn in the map. So once I enable this, we'll see we don't get those cased endings, those caps anymore. We get a nice smooth drawing experience where the symbol, this like peachy colored symbol layer, will display on top and the other symbol layer displays on the bottom. And this is done through a symbol layer drawing property on the feature layer. You can enable this, and that's what I'm doing here, just switching between enabled and disabled. And then that'll pull from a list of the names of each symbol layer in the map. I didn't want to show that in code because it's much easier to see in Map Viewer where we have the authoring experience for this. So if you go into the styles pane, into the style options and scroll down, you'll now see that we have the symbol layer draw order with a very similar authoring experience of what you see in Pro, where you can decide whether you want to join and merge, and enable and disable the symbol layer drawing. And then you can also go into an advanced route where you can see exactly the order that the symbol layers are going to draw. So first I see this interstate, layer 2, then layer 1. That's that first symbol. And you can drag these around and move things around. So let's say I want this one to display above. I mean, that doesn't look very good, but you have full control over how this works. So yep, that is symbol layer drawing. The last feature that I'm really excited to announce is released in beta is the animations along a line. This is supported on the sim symbol. It allows you to move markers along a line. And this is done through this new animation type that is, again, in beta called sim symbol animation move along line. This can be useful for visualizing routes, traffic patterns, any type of movement. So here we're looking at a routing application. We have a sim line symbol with two symbol layers. One, which is the sim vector marker, which is representing this little arrow, this little white arrow. And then the other, which is a sim solid stroke, which is this blue line that you see behind it. And the marker placement of the arrow symbol is defined by this marker placement property. So once all of that is defined, then we can go ahead and add the animation here. Set the movement type, which in this case is speed. We have a speed of 25 and we're setting it to continuous so that it'll continuously animate along the line no matter what the duration is. We can play around with some of these properties. Let's say we want to increase the speed and run the code again. And I'll just go ahead and draw a new route on the map. And we can see the route moving much faster. Again, this is supported in the map viewer. So what I've done, and thanks to Jose for this demo idea, since I live in New York, he was like, you should draw an animated route of the Knicks parade. So I added this media layer of the parade route in map viewer, and then I added a sketch layer to show the route of the parade. So we can easily update this feature to use an animated symbol in the symbol gallery. If I go to animated vector symbols, it provides a nice variety of animated lines for me to choose from that are predefined. You don't have to write out that huge symbol JSON on your own. So I can go and just set the animation here. If I want to adjust any of the animation properties, I have full access to all of that through the symbol styler. But I wanted to take this a step further with a custom route or a custom symbol. So I created a little animated basketballs just to show kind of the flexibility of how you can take this new animation type, add your own symbols, and kind of animate things along. So I created these basketballs from an SVG image, and then again, just the same thing, added this animation along the line. Again, this is still in beta. We're still working through some kinks, and we hope to have this fully released in the upcoming release. And then Map Viewer will also support kind of adding on animations to any of your existing symbols. So yeah, that's all I had to show today. Back to you, Emily. Thank you.
Thank you, Anne. This is amazing. I love all the basketball marks. That's such a great use case. That's awesome. We have a question here from one of our audience. Cool stuff, these animated symbols. Any plan to have some kind of sample animated symbol gallery to help people start up?
Yeah, that's a great question. So there is a animated web style group that we can share out. That's part of ArcGIS Online. So that's what's getting pulled into the map viewer. So those are available out of the box, and you can just pull them in as web style symbols in the JavaScript SDK. In terms of like another way to help people get started, we have the sim symbol builder. It still needs to be updated to support the latest version of the SDK and the new animations, but I'll work on getting that updated and out so that everyone can use it as like a playground for building out your animated symbols. But it will also be the upcoming release. Once these are out of beta, you'll have that full control in Map Viewer as well. So that will probably be the best place to author them, because as you could probably tell by the code, the sim JSON is a bit long and hard to author by hand.
Yeah, that's a great question. And we will post a link for our web style symbols offering in the chat for you to refer later. Okay, great. Thank you, Anne. And for the audience, if you have any more questions, just post it in the chat and we will get them answered as well. Thank you. Yeah, and next up, we will have Anjol sharing updates for Parquet and some amazing web map, amazing 2D map updates.
Thanks. Okay, so I'm gonna share my screen. Can everyone, hopefully everyone see my screen. Okay, so I'm here today to talk about enhancements to ParquetLayer and hit test improvements for map view and map component, and also 2D support for M and Z values. So I'm gonna start with the ParquetLayer enhancements. So ParquetLayer is still in beta, but it continues to get a lot of performance improvements, new enhancements and features at every release. And 5.1 was no exception. We've added a lot of cool enhancements to this layer. So next few minutes, I'm gonna go over this ArcGIS Online blog written by our coworkers Jessica and Sarah, and they talk about what ParquetLayer is, and then also enhancements specific to ArcGIS Online. And I believe the link is being shared in a live session chat. So be sure to check out the contents of this blog if you want to learn what ParquetLayer is and have to take advantage of the enhancements for ParquetLayer in ArcGIS Online. So let me give you like a 20 seconds the introduction on what ParquetLayer is. So ParquetLayer allows you to visualize the contents of your Parquet files, either on a map or feature table component or in both, okay? And Apache Parquet file is an open source file format, which allows you to store your data in a columnar format. And this columnar format makes it more efficient to store, read, and fetch data out of those Parquet files, making ParquetLayer a performant layer, okay? And then the GeoParquet is an open source spec that allows you to store your geometries in a Parquet file as a binary format or as a well-known binary format. And those geometries are stored in a separate column, basically in WKB format. Okay. So now I'm going to go back to the ParquetLayer enhancements. At 5.1, now users can create Parquet files using ArcGIS Online data pipeline And if you're creating your Parquet files using the data pipeline, then you can take advantage of two enhancements that are specific to data pipeline. So first one is the Parquet file will store all geographics near each other or adjacent to each other in similar area in your Parquet files. Basically, they're going to be in the same parts of your Parquet files. And if you're doing a spatial query, then your spatial query is going to be much more performant because JavaScript does not have to read the entire contents of the Parquet files to find all the features that meet your spatial query. Instead, it's going to find the section in the Parquet file and then fetch the features that meet your spatial criteria. So this means reduced time when you're doing spatial queries, for example, when you're displaying your features on the map. The second one is multi-scale geometry. So if you're creating Parquet files that stores polyline and polygon features, then what will happen is the Parquet file will store several optimized geometries in separate columns in your Parquet file, and each optimized geometry is going to be optimized to specific level of detail or scale. So as you are zooming in, zooming out on the map, the JavaScript will read the optimized geometries for that given scale from your Parquet files. So when you're zooming and zooming out or interacting with your map, the geometries are going to draw much faster on the map, just like here in this GIF you were seeing. Next. So now I'm going to go to actually the ParquetLayer SDK doc. So because now users can create Parquet files using ArcGIS Online data pipeline, those files are stored as ArcGIS Online portal item, and you can consume those portal items directly via the ParquetLayer now. So to accommodate consuming the ArcGIS portal item, we've deprecated URLs property on ParquetLayer. Instead, we've added this data property. This is new at 5.1, and you can set the data property either to point to the URLs of your Parquet file like we used to, or you can set the data property to ArcGIS Online portal data as shown here. So if you're using ParquetLayer already in your applications, be sure to use data property over URLs property, okay? And we've also added the support for definition expression for ParquetLayer. Now you can filter out the features from your ParquetLayer based on given definition expressions or basically based on the attributes of a given field. We have also removed all the known limitations from query features method. At 5.0, you were not able to run spatial statistics, or you were not able to order the results of your query based on a given field or fields, and all of those known limitations are removed. So you can call query features with just like you would for any other feature like layer. Next, also, we removed the known limitation for hit test for ParquetLayer. So at 5.0, if you've used the hit test method either in the map component or map view, and then if the hit target intersected with any features from a ParquetLayer only returned the topmost feature in the hit test result. Now we've removed this, and hit test will now return, ParquetLayer will return all of its intersecting features in the hit test result. Okay, so that's about ParquetLayer enhancements. Now I want to segue into hit test enhancements for map view or map component. So we just talked about the ParquetLayer enhancements for hit test, but also at 5.1 we added support now imagery layer, and imagery tile layers will return hit test results if their features intersect or images intersect with hit test. And imagery layer and imagery tile will return basically a result containing the hit pixel values and band IDs and several other information. And more of an exciting enhancement for hit test is if you've used hit test, you all know that for the hit target, you can only pass in screen point or your pointer location from your mouse or pointer events. And then the hit test returns results intersecting with that screen point or your pointer's location. But at 5.2, we've added a support for screen rectangle. So now users can pass in a screen rectangle as the hit target, and hit test result will return all the features that intersect with the screen rectangle. So we've added a new sample to showcase this new exciting enhancements. So on this map here, you're looking at a population change information for each census block within United States. And then the larger the points mean that if they're green means there was a big population change for those census blocks. The purple means there was a decrease for those census blocks. So bigger the point means there was a large increase or decrease in population change. Smaller means there was a small change. So that's what the map is showing. And then also you can see in the middle of the map, we have a screen rectangle, or rather a screen square. And then as I'm moving my mouse or panning or zooming out on the map, you can see we are selecting features that intersect this screen square and highlighting the features. And then also, if you notice, we're updating the what is it called? The calcite list on the right-hand side. And then these are interactive. If I click on them, I will get an additional information about this census tract and the population information. So this application is being basically driven by the new enhancement we've just added that, again, 5.1, the hit test, the screen rectangle hit target. So here we are calling the hit test method, as you can see, and then we are passing in the screen square that is visible on the map. And then, of course, we have a function to get the screen rectangle. You can take a look at it later in a sample. And then the hit test result returning all the features that intersect this rectangle. And then we simply just highlight the features and populate the calcite list. So that is the enhancement for hit test, and we are also are also planning on adding a screen polygon hit target at 6.0 or in future releases. So be tuned for that. All right. So next, I'm going to talk about support for returning M and Z values in 2D map or 2D map view or map component. Okay, this has been one of the most requested features by users, so this should be a very exciting enhancement for a lot of you, I hope. Okay, so now M and Z values of the features will be fetched as part of the 2D rendering queries if your layer has a M and Z aware features. Okay, but the decision to fetch the M and Z values will be defined by the values of the return Z and return M properties on a layer that supports those properties. And these properties can have three possible values: undefined, true, and false. Okay, so if and then undefined is the default value. And then if the return M and return Z are undefined, and then if the layer does not take advantage of its M and Z values anywhere in a layer configuration in the application, then 2D rendering queries will not fetch the M and Z values as part of its rendering queries. But if the return M and return Z are set to undefined, and if the layer uses its M and Z values anywhere in the application, then the 2D will fetch the M and Z values as part of its rendering queries. So for example, if layer is displaying the M and Z values as part of its layer labels, then the M and Z values will be fetched as part of the rendering queries, and MZ values will be available as part of the feature geometries on the client side, and you have access to those. If you set it to true, then the API will fetch the M and Z values always, even if they're not used anywhere in the application. If you set the values to false, then the API rendering queries will not fetch the M and Z values, even if the layer uses its M and Z values. For example, if you're again displaying the M and Z values as part of its labels, M and Z values will not be fetched if those values are false. Okay. So let's take a look at this in a really simple example here. For example, in this application, we're just adding 3 points. You can see now the label indeed displays the Z values in this case. And then there are 3 points, and then you can see that Z value is showing a 3.048 in this case. So let me explain one thing about Z value measurement, okay? So Z values are measured in vertical unit of the vertical coordinate system of the spatial reference of the service, sorry, a lot of offs, if the service has a vertical coordinate system. If the service doesn't have a vertical coordinate system, then Z values are measured in a linear unit of the spatial services horizontal coordinate system. So if I go to, so this service here, if I go to the service on the map, this service, let's take a look at the spatial reference here. The spatial reference for this service is in what is it, state plane of North Carolina. Okay, so this is the spatial reference. Actually, where's the spatial reference? Let me just go back one level up. So this is the spatial reference of the service. And because the service doesn't have a vertical coordinate system, then Z values for this service is going to be measured in a linear unit of the spatial reference. So if you take a look at the spatial reference information, this is a North Carolina state plane projection. And for the state plane, North Carolina, the linear unit is US foot, okay? So then we know the Z values in the service are measured in a US foot. So if I go to the REST API, as you can see here, I fetched all the features from the service and displaying the requested to return the M and Z values, and then M, Z values are being displayed here. So if you look at the value for the last feature here, the Z value is 10. And because this service is in a state plane of North Carolina, like I said, the linear unit is feet, and this value is being returned in US feet. Okay. But in map view, when we present the Z or Z values to users, like in the label here, we always scale the Z values to the linear unit of the map's spatial reference. Okay. So in this case, if I also click on the pop-up, you can see also the Z value is being presented in 3.08, even though the store Z value is M. So in this case, what we're doing is we are converting that 10 feet to, in this case, because we're displaying this data in the Web Marketer app, we are converting this value to meters, because for web marketers, the linear unit is in meters. Okay. And then if I, let's say, switch the map spatial reference to WGS 84, which is a geographic coordinate system. So in this case, if your map's spatial reference is in geographic projection, then the Z values are measured in meters or displayed in meters. Now, if I change the spatial reference to state plane of North Carolina to match, basically in this case, we're matching the services spatial reference. Now you can see the Z values are being presented in US feet, okay? So this is the behavior that scene view also displays. Basically, we always present the Z values in a linear unit of the map spatial reference. Okay, so this concludes my session. Back to you, Emily.
Great. Thank you so much, Anjo. We have a few questions from the audience. So first, with 119 Shu B, the question is, how can I create ParquetLayer from existing 2D files?
So I think the easiest would be, again, use the ArcGIS data pipeline. You can pass in different sources to create Parquet files. It can be feature service or other types of files. And then the blog I referred to earlier talks about how to create or generate those Parquet files using ArcGIS Online data pipeline. So I'd suggest checking out that blog and follow the steps.
Yeah, that's awesome. And also want to mention that currently it's for data pipelines only, but in the future, there will be other workflows available as well. Great. And our second question is from Hercule Jacob. Based on my testing, fetch pop-up features and hit test only appear to work on web map loaded layers in 5.1. Is that an intended behavior?
I don't know what that means. Is he talking about like a hit test not working on non-visible layers, like the visibility is turned off? And so I guess I'm not clear on the question. We can follow up on that, but hit test will only, yes, work with only visible features on the map.
Got it. Okay, thank you. Yeah, so if the Hercules Yakko, if you can post your, give us more context on your question, we will help you in the chat as well. Thank you so much. Great presentation, Anjol. And next up, we will have Jose covering our great updates in the editing field.
Thank you, Emily. I'm going to share my screen. Okay, so we've had a few features released on drawing and editing, and I'm going to start off with the drawing enhancements and use Sketch to showcase the drawing enhancements. What I show right now is also going to be available through the editor component. So one of the new features that we added was the tangent curve segment tool. So this completes the circular arc tools that we wanted to support on the web with the arc segment and endpoint arc segments. These are the tools that were already available through desktop and pro. And of course, we also support the Bezier curve segment. So while you're drawing your geometries, whether it's a line or polygon, you can now have the ability to draw the tangent curve just like the existing ones. And since it's a circular arc tool, um, it's available to be saved in ArcGIS Online and Enterprise. An additional feature that we added was supporting segment labels in 2D. This was already supported in 3D, but as of 5.1, it's now in 2D. So all you have to do is go to the settings menu underneath the tooltips and enable the segment labels to check that on. What this allows us to do, again, for lines and polygons, is to visually see the distance for each line segment. So I'm going to use the tangent curve since showing off the new tool. So we can see the measurements as we're digitizing these geometries. So the segment labels are available while creating the geometries, but also in the edit vertices mode. So I'm going to adjust the curve manipulator to just the radius of the arc here, and we'll see the values update as well. So it's a new feature that was already available in your 3D applications and now are available in 2D. As I mentioned, this is available both in the sketch component and the editor component. On the editing side, we added support for a new input type, and that's the multiple choice input. Here we have a data set for road incidents, and let's say a user reporting a incident on the road for North Street here. We see a form with a multiple choice input. So the multiple choice input depends on a string, a native string field. And you, as a data author, you have to manually set up the choices you want to be available for a user submitting your form. It could be done through the Field Maps Designer application or programmatically through the Maps SDK. And I'll share how to do both. So just like any other field elements, the multiple choice input allows you to set the fields as required, as editable or non-editable, visible or non-visible. You have the ability to select all choices or deselect them. This select all is an option that be configured to be turned on or off. Additionally, I can set a minimum or max choices that I want the users to uh, respect before they submit their edits. Here I have at least one option has to be chosen from the choice list here before I can submit the form. So I'm going to check the trash choice. Additionally, we have the other field input, which just like any other field in any other form using multiple choice, there's always an option to provide a custom input that's not available in the choice list. So I am going to say like tire. So now I'm able to submit this particular form. One important thing to know is the other input choice doesn't count for the min or max choice count requirements. So here, as I mentioned, I had one, you had to check at least one choice. And even though I have the other choice with a value, I still need to check one of the choices provided. So I still have to go back and, check the trashed choice. I'm going to submit the reported date. And just like the single edits, the multiple choice input is also available in batch editing. So here we have a check for the trash. So that means both of the features have the trash choice checked. When you see this minus sign, that means one of the features has it and the others don't, or at least one feature has it. And then also for the other incident type is checked, but they have different values. So if we were to go back, we see that the trash and flooding are checked with garbage and tire as the description. But for this other one, we have just the trash and then the tire on the road. So I can make an edit for both that can be preserved for both. So I'm just going to add the fire and then submit. So it's supported, multiple choice input supported for both single editing and batch attribute editing. The way we configure the multiple choice is through either the field maps designer. So here I have the layer opened in the map viewer and opened through the field map designer application. I choose the string field, which is the request type field, and I set the input type as multiple choice. Once you set it as multiple choice, you have this choices button that allows you to manually enter the values uh, that you want to provide for the choice list. This can also be done by uploading like a CSV file as well, but I'm going to show you how to manually do it. So I've entered 6 already. If I wanted to add a new one, I would just type it here and hit done. But I won't save this one. You can also specify min and max choice, just like I showed earlier, with the select all option can be turned on or off, as well as the other option, and the custom placeholder text. So that's how you can do it through the field maps designer. If you wanted to do it programmatically, this is the code. The application I shared was using this code. So we have the 6 options available that are set here in the choice array under the multiple choice input. And I set the minimum choices to 1 and the select all checkbox, turn that one on. You can configure the placeholder, the custom placeholder text here, as well as the label. It's important to note that in order to support the other choice option, you need to have a secondary string field where that value is going to be preserved. So for this data set, we had uh, the request type as the multiple choice uh, field. But if you click on the gear icon in the other option, you'll see that there's a field called other request type that stores the value for the other custom option that a user can provide. As a reminder, the request type is a string field. So if we were to open the data set in a feature table, since feature table doesn't support multiple choice, we'll see that the multiple choice list gets parsed into a string that's is comma delimited. So you'll see the value separated by a comma. And this is the other request type field where the values that are custom, not part of the choice list, are preserved in this field. So that was the multiple choice input. Uh, Another new form element that was added was attachment element, and that can be highlighted using this Jimothy sightings application. For those who are not familiar with Jimothy, it's a cute raccoon that's been spotted in the neighborhood of Ballard in Seattle, Washington. So he's a cute raccoon with a shortened spine, so he's kind of a phenomenon, and everyone's trying to capture images or videos of this raccoon. So with here we have a sightings to showcase the new attachment element. So we're selecting an existing uh, feature that has been logged. In this attachment element, you can configure whether you want which types of files you want to be uploaded, and I'm going to show how to do that through the Field Maps Designer. So in this example, I'm restricting it to only provide, a user can only provide images, not video. So if I were to try to attach a video, it's going to not allow me to do that. It's going to say file type not supported. In this new pane as well, you have the some additional information. It says that there's a minimum number of files requirement that are provided. So if you're trying to submit a new feature without an attachment, it won't let you. And we have max pixel count of 1280 as well that can also be configured. If you were to inspect the images, we have the ability to now uh, maximize them so you can see the images in a larger scale. We have the ability to download and replace the images as well as update the file name. You can also see the size and type of file. So if I were to go back and try to add a new sighting, let's say um, behind this grocery store in the parking lot, I'm going to add the sighting, uh, parking lot. So if I try to submit the edit right now, it's not going to let me because it hasn't satisfied the minimum requirement. So I'm going to select the file and I'm going to use the parking lot one. So now we have the pending edit and I can submit. If we want to see how the attachment element was configured for this example, we can go through the map viewer and we'll go to the forms, configure editing. So on the right, we'll see the attachment elements that you can use. The general attachment element allows you to update any supported file type like document or media. Document only allows you to submit document files like PDF, Excel files, Word documents. For example, media allows you to submit images, videos, or audio, but for the web, we're supporting the images and videos. So you can just drag them over. You can add as many as you like. This only has one, which is the media. So if I click on it for more information, we'll see it's restricted to photo. I can add a new one that it's just video, but for this example, it's for photo. You can choose whether you want to allow existing photo or capture um, in your application. For the web, we only support existing capture mode is only supported for mobile users. We have the minimum file count that I set here. You can also do a max file count, and then the upload size can be controlled, so you can force it to be like less than 320 pixels, or even a custom value. And you can configure other options as well as controlling the editability and visibility of the field. So that's the attachment element that was supported. If you I shared how to do it through the Field Maps Designer, but if you wanted to see an example of the code, you can look at our sample where my teammate Heather Gonzago added the attachment element examples. You can see how to set this up through code as well, and that'll be shared. And also, just if you want to know the limits, the file types that are supported for each of the general, document, and media attachment elements, this link is also going to be shared. Uh, that's end of concludes my editing section. So Thank you. Back to you, Emily.
Thank you so much, Jose. This is an awesome session, and it's always good to see Jimothy, to see where he's been. That's great. And yeah, I don't think we currently have any like editing related question, but I think we have some other questions to be answered, and we will address them close to the end of the live stream. Thank you, Jose.
Sounds good. Thanks, Emily.
Great. And next up, we will have Katia talking about our 3D updates.
Thanks, Emily. I'm excited to present the new 3D features the team has worked on for this release. And I'll begin with showing you the Gaussian splat layer. We first added, I want to show you some visual improvements we have added. We have worked on adding smoothing as you navigate and interact with the scene so that the layer comes in gradually and doesn't break continuity in the immersion. And the layer now also participates in scene shadows. So if you look at under the palm trees, I can turn on the shadows and you can see that they're outlined here. And they also adapt to the time of day, so you can have these realistic effects available to you. We have also added support for different 3D analysis tooling to work with the Gaussian splat layer. For example, I can do the line of sight analysis to see what's visible from the top of the Ferris wheel here. I can also use the slice tool to inspect the structure in more detail that's captured with the Gaussian splat layer. And I can also do the elevation profile analysis, so I can look in more detail what kind of thrills I can get on this roller coaster. Lastly, the layer also now supports clipping areas, so you can focus in on a part of the scene that's relevant to your workflows. Next, I want to talk about extracting models from 3D object layers. You can now query the source and the derived models that are associated with a 3D object feature on a 3D object scene layer. You can query it for the available model formats. You can request a specific format and then download the model files on demand. And that can be quite useful when you need to extract specific data from a project. So for example, here I will pick a building and I'll query that object and I can get the source model for that object, which is the shape buffer file. And I can also get the models in different formats that are the derived models. And in this code, it looks like this. I would use the query models method on the scene layer. To get the models, they're returned and grouped by the object ID. And when they're returned, they contain some useful information, like the actual files that make up the model, like the GLTF file with the related texture files. It has the file format that it's in, has the size, which could be useful for downloading, and it also tells you if it's a source model, so the source of truth for this feature, or it's a derived model. And if I found one that I like, I can download it, and for that I would use the query model method without the S, to which I would pass the object ID and some options. Options define whether I want the source model for that object, or if I want one of the specific formats that are present. And then I can trigger a download and get the file here. And if instead you want the displayable mesh geometry rather than the source and the derived model, that's also possible with the scene layer query features method. You have to set the return geometry parameter to true. And that gives you the geometry as a graphic containing a mesh. And for this information and more details on 3D object workflows, we have updated this guide page, so you can take a look and learn more on how you can work with 3D objects. We'll link to it. Next, I want to go over the updates to different 3D tools that we have worked on. I'm excited to show you the sunlight duration analysis, which is a significant update to the shadow cast analysis. So you can now not only evaluate how much time a certain point spends in shadow, but also how long it is lit by the sun. So that could be quite useful for evaluating whether a new building proposal leaves enough sun exposure to the surrounding buildings, which is especially relevant in northern countries in winter months. So as I update the elements of the scene, the calculations for the sunlight exposure also change. So in this example, we're looking at the worst case scenario, which is the day of the winter solstice. And you can see here I'm setting up a shadow cast analysis, which you're familiar with. We have added this new property, visualize sunlight, which converts it to a sunlight duration analysis from a shadow cast analysis. The sunlight visualization is supported for all shadow cast modes. So here I'm using total duration, but you can use others as well. I pick my date, start, and end times for the winter solstice. And I can also set the geometry, which is a new property we added to limit the analysis to just a particular polygon so that you're not seeing extraneous details that you might not be interested in, like outside the parcel that we're focused on. Another new property we added is the color stops property on total duration options. And that's great because it lets us customize the color ramp that visualizes the results. So here it goes from this darker purple color in parts of the scene that have the least amount of light and to yellow when we have the most amount of light. You can also see here we have some labels and they're kind of displaying the light information at that point. And that's possible to do by using analysis view get duration at screen method. So we convert these 3D points to a screen point, which you see here, using view element to screen. And then we use analysis view get duration at screen to get the sunlight duration at that location, then display it there. And the last change is you see we have this nice tooltip here that shows a range, 4 to 5 hours or 5 to 6 hours, depending on where I'm hovering, instead of a specific time. And that's done to improve the results when we're in an hourly total duration mode, where the exact time doesn't make exact sense with the data. Next, I want to show you the elevation profile groups. So elevation profile analysis now supports groups, which is a new profile type, which you can use to organize multiple profile lines into logical containers. So it could be useful when you want to separate elevation sources or different data groups apart from each other. So in this example, we have one group that's comparing the pre and post landslide elevation data, and one that's providing just the overall context of how things are now in 2026. And the way you would do that is using the profiles property, which is a collection. Instead of just setting the individual profile lines, you can also define a group. And the group also has a profiles property, which is a collection. And in there, I'm listing the profile lines that are part of this collection. Like in this case, the pre and post landslide data. I give the source of the layer and name and some color styling information. And that lets me visualize things a bit more clearly. Next, we have the viewshed, which now supports the elevation info property, which could be really helpful in workflows where the observer needs to be either at a fixed altitude, placed on the ground, or relative to scene. So in this example, what I'm curious to know is what can I see from the rooftop of these buildings? So I picked the elevation info mode relative to scene because we're relative to the buildings here, and I set the offset to 1.7 meters, which is about the human height. And so what happens is when I move the handle of the viewshed analysis, it will move up and down to keep that fixed height above the buildings. So going higher when the roofs are a bit higher and going lower when the roofs are a bit lower. And this can also work for other elevation info modes like absolute height and relative to ground. So this gives me certainty that I'm always at a certain altitude, no matter how much I'm moving the viewshed. And lastly, for tools, the volume measurement component and the volume measurement analysis are now out of beta and in preview. The key distinction is that in preview, the capabilities are already stable and production ready and in the final stages of productization. And if you want to know more about the definition of preview, I invite you to open the link here in the pages for the component and the analysis, as well as in the release notes. We have it here, and it's also linked in the live stream. Now I want to briefly show you some changes and improvements to 3D navigation. Specifically, we added an option to force horizontal panning. So right now, horizontal panning works in a way where if the camera is tilting down, when I pan horizontally, but when the camera is tilting up, when I pan vertically. But there are scenarios where I would want to pan horizontally regardless of my camera angle. For example, if I want to move down the street while looking forward, If I try to pan now, I will pan vertically rather than going forward. So now we've introduced the B modifier key. If you press down B and use the right mouse button, I can grab the ground and pan myself forward and back, side to side, horizontally, while also looking forward. And this also works with the existing combination of the B modifier key and the left mouse button, which lets me rotate and look around in place and inspect the assets in the scene here. So combining the look around rotation and the horizontal panning, it's helpful for these constrained environments like navigating down street canyons or exploring indoor scenes. And you can find this in the scene navigation page. And I want to finish by covering the visual improvements we have worked on in 3D. So the first is the 3D polygon tessellation. We improved this so now we can handle polygons with multiple rings, holes, or self-intersections. So these very complicated polygons look like they do in 2D and will look more accurate. So you see here on the left side, in the older version, we don't always correctly find the bounds of the polygon, while in the new version, in the new release, we do. So you can visualize your complex data much more accurately. And lastly, we have improved 3D visuals on iOS, specifically on devices that are missing the Float Blend WebGL extension. So that's a lot of older iPhones and many iPads. Before this release, they did not support emissive materials in Glow. So you see on the right, all these red buildings are not emitting light, while on the left they are. And also we have added support for order independent transparency, or OIT, which you see in the new version. You can clearly tell these are many stacked semi-transparent volumes, as opposed to on the right where it doesn't look quite correct. It looks like just a transparent shell with no depth inside. So order-dependent transparency helps depth perception and more correct reading of transparent data. And this also brings the visuals on these devices in line with other devices, so everything looks consistent regardless of the devices you're on, desktop, mobile, iPhone, or otherwise. This concludes my presentation. Thank you for listening, and a great shout out to the entire team that worked on these wonderful features. I'll pass it back to you, Emily.
Amazing demo, thank you. It's really great to see that all the advancement we make for the Gaussian splat layer especially. This is great. Thank you for sharing. Awesome. So next up, we will have Russ talking about our latest layer and label updates.
Cool. Let me get the screen share up. Cool. Alrighty. So first I'm going to talk about displaying annotation dimension layers. At this release, in 5.1, they are in beta. And so this is primarily just displaying these within your 2D maps. You're able to save these layers back to your web map, and you can use the dimension layer, the annotation layer, the sub layers within the annotation within the layer list component as well. Just to also highlight, like, they are in beta, so we do want to hear your feedback. We're going to be working on additional rendering support for like text formatting tags like color, bold, and font. And if you have any recommendations for other formatting tags we should prioritize, please feel free to post it in the chat or community or LinkedIn, and we'll happy to follow up. Also, these are all coming from enterprise server. So at this release, we're not publishing annotation or dimension layers to ArcGIS Online. They are coming from an enterprise server, and then you could bring it into, let's say, a map viewer by URL and author that web map and load that within the JavaScript SDK or another application within online. And just for reference, for the annotation layer, these are primarily just being used to display a specific text. It could be like a street name, a parcel ID, or like a fire hydrant ID as well. And then for dimension layers, you're kind of giving more of a specific symbol rule set for showing kind of like the distance between, let's say, your water line and a parcel or that like fire hydrant, to help make some adjustments to the visual analysis that you're doing here. And so as well, like if you're zooming in and out, we'll also update the kind of dimension arrows to appropriately style as they've been authored. And so just a quick kind of viewing into this. This is just showing the display only option where I've brought a dimension layer and an annotation layer into a web map. I've just organized these with a group layer. But so if I just disable the visibility of the water dimension layer, you can just see that the arrows kind of turn on and off. And then we go into the more complex case, and we go to this individual annotation layer. Here, this specific annotation layer has multiple kind of annotation classes. And here through the layer list, I'm able to control the visibility of it. We also support feature-linked annotation layers. And so what this means, you can have in that single feature layer that you publish to your enterprise server, you have, let's say, one that's parcels, and then you have your annotation layer. When you make edits to the parcel layer, it will also update the feature-linked annotation layer to display the correct text. So you could be using editor like Jose showed, and you'd see the edits being made to the parcel, and then the annotation layer kind of accepting those updates and updating the text appropriately. Next up, we've made a few changes to the support that we have within the 2D feature layer labeling and the fonts that we support. So this release 5.1, we made a huge leap with being able to display text from languages that have complex characters. And so from user feedback, the top ones on our list were these Khmer, Lao, Myanmar, and Thai. And so we are now using WAF2 fonts to render this text, while all the other fonts that you see available that are hosted within ArcGIS Online, as you go down this list here that you can see on the documentation page, majority of those are all being delivered through a PDF format. And while we will be using for these complex characters to be able to make sure that the multi-part shaping is accurate, we're using the WAF2. And so these are the initial fonts that we're supporting with this new rendering of the text. And if you have any feedback or request additional fonts, please also reach out to me and community and elsewhere. And we'd be happy to looking at expanding the fonts that we support for these complex cases. And just as a heads up as well for the kind of pro to web story, if you want to be able to author these without having to either mess with your code or web map JSON, you can just download the fonts that we've kind of had recommended here along with the PBF ones. And when you install those and you're using Pro to label your features and you share that to the web, we'll be able to match that font family and weight to the list of supported fonts that we host in online today, and then accurately kind of map them for your labeling requirements in the web. So just to jump over, here's one of the cases here where I'm looking at Khmer, and I'm just using the attributes for the different farm names here, and I'm just using the Noto Sans Khmer, and I have the same, capabilities as with all the other kind of fonts that are using the PDF format, where I can use halos, I can use a background text, I can use bold, regular, all of the same thing. So it's pretty transparent to anyone using these fonts to label their features. But behind the scenes, you'll notice that the non-complex character cases will be going to like a PBF endpoint versus these scenarios here. We are going to the WAF2. We've also made some updates to fonts that improve accessibility. So at this release, we've also added support for Atkinson Hyperlegible and Barlow. And both of these fonts are available in ArcGIS Online today, and they'll be available in 12.2. And so these fonts are helpful for people that could have dyslexia or poor vision. And like in some of these cases here, you can see like the 0 is very well defined with the strike through. While if you look at an O here, they're very distinguished from one another, so you can't confuse them. Same thing with like L's, I's, and 1s. And so this example here is using the Atkinson Hyperlegible Next. And so you can check that out in Map Viewer or also in the documentation page. And so that was just a quick run through of the labeling and dimension and annotation layer support. And I will toss it back to Emily.
This is great. Thank you so much, Russ. So I just wanted to make it, so for all of these great features, are they both available in Map Viewer and also programmatically as well?
Yes, yes. Yep, both are available there. And so if you're using these fonts or these annotation layers and you're saving them to a web map, let's say in Map Viewer, and then you're just bringing in the web map, into your application, it'll render there, or you can explicitly call out those fonts in like your text symbol and the weights that we support within static, and then we'll render those without having to, use a web map.
That's great. That's always good to hear. Thank you so much, Russ.
Thank you.
That's amazing. We also have one quick question from our audience in the chat. It's about feature layer. Sorry, it's about vector tile layer versus the new Parquet feature layer. So Ross and Andrew, can you help answer the question about what are the best scenarios to choose one over the other? Like, what's our recommendations?
Do you want me to take this one, Russ?
Sure.
Okay. Sure. Okay, I can try to answer. So, ParquetLayer is just like any other feature-like layer. If you work with a featured layer, JSON, CSV, WFS, those layers that give you full access to geometries and attributes of all the features they're serving, right? And because you have access to the attributes and the geometries, you can do a lot of spatial and attribute analysis. You can run statistics. You can apply nice spatial filters because you have full access to all the features and attributes of those the geometries and features of those attributes. You can set pop-up, and also in the future we are planning on adding support for editing, and then also the features will be M and Z aware. So it gives you again full access to all of the features, and then you have basically full control over what you can do with the attributes and features of your feature geometries of features being served through your Parquet files. Versus vector tile layer, you have to prepare the data, and once the data is served, we are consuming vector tile consumes the pre-cooked tiles of all the features, right? Then one thing about vector tile layers, every vector tile layer has a style associated with it. So you're not just only serving out like a static tiles that's just a pre-cooked, that's images that you can't do anything with. Instead, you can go into the style JSON and you can change the look and feel of the layers being served through the vector tile layer. But you don't have access to the geometries or attributes of those features that's coming in your vector tile layer, and you can set pop-up, you can run analysis. But vector tile is a really good way of serving large amounts of data from many different layers and then presenting it as base maps to users. So I would say vector tile is a really good layer to use as base maps because everything is cooked and you can change the style of it, but they're also very fast and performant to present that data to users. So hope this helps to clarify the question.
Thank you, Andrew. Is there anything you want to add, Russell?
No, I think Andrew nailed it. Yeah, it's the Parquet feature layer you're going to be using for, like you could style it, you can filter it, you can label it, analysis, and you're doing that. You can do that on the fly versus the vector tile scenario. You're using it as like a visual reference, as a base map or reference layer, and you're locked into then using the style file to, show or hide things as you need, but you're not using the filtering or labeling or styling like outside of that style file.
Yes, that's great. That's good to hear. And again, like for operable layers, so any layer you want to edit, like we recommend using like feature layer. That's still the recommended way to use for any data that you need a lot of interaction. But ParquetLayer just provide a great option for you to use for the layers that you want to filter, you want to query, but you don't need to edit or some form. You don't need to edit. So great question. Thank you. And I am going to wrap this up with like a quick introduction on our documentation updates. So I'm sharing my screen right now. So first of all, if you look at our SDK documentation site, and we have a showcase section. This is a completely revamped area. Our goal is we have these like showcase applications that are taking the functionality one step above the samples. So our samples are very targeted solution to show each of the individual techniques and capabilities. But these like showcase applications are ways to show you how to combine the functionality. Like a good thing to like inspire you to see how to take your application to the next stage. The best part is for all the showcase app. We have a live demo that you can play with the application. For example, this one is the New York City helicopter noise explorer. It's taking some time to load. And yep, we're here. So all the applications are using web components that are using the promoted best practice for building application. Like all these amazing stylings are using calcite as well. And you can filter by date. Just try it out. And we have the application. So, and then the best part is you can view the code in the GitHub. So if you like this application, you can look at the code to see exactly how we put it together. And also, if you want to use it for your own project, you can fork it and clone it to your own branch. This is just one example. And then at the very end, we have the under the hood section to talk about each key features of this application, that how we combine it together. And currently we have these 9 applications. Some of them are 2D, some of them 3D, and it covers all types of cool use case and scenarios. Feel free to check them out. We hope it will be great for your future development. So that's the first thing. The second addition is we added this authentication and access token guides plus a few tutorials on this. It is just right underneath our first section in the documentation site. So this guide goes through different types of authentication, including user authentication, app authentication, and it covers like all of the product support, either you're using location platform or online or enterprise. So you can find example and document on the best way to authenticate your application. And also we have this tutorials. It goes step by step about setting up your user authentication. So we hope this can be helpful for your future application as well. Also, another good thing to mention for authentication is if you go to get started, we added the ArcGIS/create in the past releases. And with this CLI, like the OAuth and authentication will be handled in this starter template as well. And lastly, one of our favorite update. I know everybody have been asking, how do I access documentation from the older versions? And we hear you. So in the reference page, we have in the downloads and previous version, you can see a table here for you to access older versions, the API, the documentation, and also we have the older documentations like hosted in our archive site for you to explore. So this is so in this way you can access the doc when it was for that version specifically. We're going to keep adding more and more versions as they release, so keep checking on that. And this is a jam-packed session. We hope you enjoyed it. We hope you enjoyed it. And if you want to learn more information about the 5.1 release for the ArcGIS Maps SDK for JavaScript, check out our release note, release blog. And also, if you have any follow-up questions, feel free to post it in Azure community. And we hope to see you next time.
Thanks. Bye.
Thank you.
Thank you.
Thank you.